Welcome to the UG students. Now we are going to that of the JAM question solution 2023. The first questions for the JAM question solution in the organic chemistry is the oxygen formation. How the oxygen formation can take place, and related problem is given here. In that reaction, the compound, this is the pentose compound, and this pentose compound undergoes reaction in presence of the phenyl hydrazine to produces the oxygen, and the mechanism is that at first the hydrazone is formed, and then this hydrazone undergoes Amadori rearrangement, produces the oxygen derivatives. Here the compound M undergoes reaction in presence of phenyl hydrazine. It produces the oxygen N, and then this oxygen N has another probability to react with the same oxygen with that of the P, where the C2 epimerization will take place. This is the compound of the arabinose, that is the C2 OH group present in the left hand side, and this is the structure of the ribose unit, where the C2 OH group present in the right hand side, and this is the C2 epimer, and hence they produces the same oxygen on treatment with that of the excess phenyl hydrazine, and this oxygen, this the aldehyde compound, is further reduced in presence of the hydrogen nickel to produces the Q compound. So the correct structure of the Q compound is the B. B option is the correct. That is the all the OH group in the right hand side. Similarly, the ketose derivatives of the M compound is also produces the same oxygen derivatives. So the same oxygen derivative can occur between the two carbon, where the aldehyde group and the C2OH group, either it is epimer or in the ketose form. So the correct option is the B. Now we are going to that of the next problem, Simon-Smith reactions. The major product in the Simon-Smith reaction. Simon-Smith reaction is the carbene addition, generation of the carbene in presence of the zinc and copper, in the presence of the diiodomethylene, produces the cyclopropane derivatives, and these cyclopropane derivatives undergoes reduction in presence of the lithium via the radical mechanism, and give that of the product, the A product is formed. And what is the stereochemical features of the Simon-Smith reactions? In the Simon-Smith reactions, the hydroxyl group always accommodate in the above side or in the below side. If the hydroxyl group is present in the above side, then the cyclopropane rings must be come from the above side by the coordination of the oxygen with that of the alkenes. If the hydroxyl group is present in the below side, then the cyclopropane is also present in the below side. So the hydroxyl group can monitor the cyclopropionation reaction in the Simon-Smith reaction, and this is the mechanism where the zinc can coordinate with that of the alkene to produces the cyclopropane derivative via concerted mechanism. Now the next question is the rate of addition of one hexyl radical to give molecules follows the order. The radicals is the two types. One is the electrophilic free radicals, and another is the nucleophilic free radicals. If we see the energy on the free radicals, that is the sumo of the nucleophilic free radicals. Nucleophilic free radicals mainly as the alkyl radicals, and the electrophilic free radicals is the electronegative containing radicals, that is the bromine radicals is the electrophilic free radicals. Here is the examples of the 1-hexyl radicals is the nucleophilic free radicals. So nucleophilic free radicals had greater capacity to interact with that of the electrophilic alkenes. These are the electrophilic alkenes, that is the P, Q and R. But the electrophilic alkenes, the homo energy and the homo-LUMO interaction between that of the electrophilic alkenes and the nucleophilic free radicals. Here the nucleophilic free radicals has the constant homo energy, but the electrophilic alkenes has the different LUMO energy. So if we go that is the diester containing alkenes has the two electron withdrawing groups. So the LUMO energy of these alkenes is lower comparative to that of the methyl acrylate. Another acrylate contain the electron donating group, that is the methyl group. So the homolumo energy gap for the interaction between that of the nucleophilic free radicals with that of the electrophilic alkenes is lower in case of the R compound. So it has higher rate compared to that of the P compared to that of the E. So the correct option is the C. Now we are going to that of the elimination reaction. The stereoelectron requirement for the E2 elimination is that the two leaving group must be present at the anti-periplanar orientation. In the given problem, the cyclohexane derivatives, the bromine, this is the bromine compound, and the 2-star bromide atom, that is the mark with that of the bromine. In presence of the iodine, I minus, it can cleaved via the anti-periplanar orientation to produces the alkene compounds. And these alkene compounds, the correct option is the A. That is the here the 180-degree angle is maintained in the cyclic bromo derivatives. So the two marked bromine atom is leave from the systems and we get that of the phenyl cyclohexyl bromo derivatives. And similarly, the new methyl chlorides was also present the hydrogen and the chlorine in the anti-periplanar orientation. So the more substituted alkene is formed and the less substituted alkene is less amount is formed. Here this is the actually Serge elimination. So the more substituted alkene is formed as the major amount. Similar problem is given here. The chloro and methyl substituted derivative. Here the chloro and methyl, the methyl group is present in the axial orientation when anti-periplanarity is maintained between that of the chlorine and the hydrogen. But this compound is highly less stable and hence the E2 elimination is occurs with elimination is not formed. That is the hydrogen and the chlorine. So the more substituted alkene is not formed. Rather less substituted alkene is formed. Now we are going to that of the reduction problem. Reduction problem means this is the reaction between that of the Reform-Esky reaction where the zinc can react with the bromo ester, alpha bromo ester to produces the alkyl zinc bromides, and these alkyl zinc bromides can add to that of the carbonyl compounds to produces the hydroxy compound which undergoes elimination to produces the alkenes, and then these alkenes react with that of the nickel chloride and the sodium borohydride. It is the chemoselective reaction and preferably added to that of the alkenes, and the ester group remain intact and we get the saturated analog of the esters. Similarly, the chemoselective reduction is also take place. This is called Lucci reduction, where the sodium boride in presence of the sodium chlorides reduces the more selectively to that of the carbonyl group instead of the aldehyde group. Here the alpha beta unsaturated carbonyl group is reduced faster compared to that of the aldehyde groups. Another example is that here the tosyl hydrazine in the presence of the paratolyl sulfonic acids in DMF in presence of sodium cyanoborohydride, the carbonyl group is removed to produces the cycloalkane derivatives. These problems have been taken from that of the Carothas groups. And this is the interesting diagram taken from that of the Claydon groups, where the sodium cyanoborohydride can reduces only the imine derivatives. That is the red color containing portion is the reduction power, and the imine derivative can be reduced to the corresponding the alkyl amine derivative, and sodium borohydride can have capability to reduce the aldehyde and the ketone derivatives, but it has lower tendency for the reduction of the ester, amide and the carboxyl group. And lithium aluminum can have capability to produces the different type of the alcohols, and the very interesting is that amide can be reduced to that of the alkane, and the boron can reduces the HR capability to that of the carboxylic acids. Now we are going to that of the ylide addition. What is the ylide addition? Ylide can add to that of the carbonyl group, produces the epoxides, or it can sulfonium ylides can add to that of the alpha beta unsaturated carbonyl group via the 1,4 addition. The sulfur ylides comparatively behave differently with that of the phosphonium ylides, where the Wittig reaction we get the carbonyl compound to that of the alkenes. Here the sulfonium ylides can add to that of the carbonyl, but here the alkene is not formed, 4-member ring is not formed, Rather, the epoxide ring is formed to give that of the epoxide compound in presence of the sulfonium halide. But if we see that of the sulfoxonium halides or the stabilized halide, then the 1,4 addition will take place. In presence of the stabilized halide, the 1,4 addition will take place. That is, the sulfonium halides undergoes 1,4 addition to give that of the cyclopropane derivatives, but the sulfoxonium halide gives that of the cyclopropane derivative, but the sulfonium halide after 1,2 addition gives that of the epoxide derivative. This problem is similar to that halides formation. Here the halide is formed and then add to that of the 1,4 addition, and after the reduction with that of the nickel hydrogen, you get that of the cyclopropane derivatives. That is, the A option is the correct option. This is the stereochemical conformation where the tertiary butyl group mainly go to that of the equatorial orientation. In the first problem, both the tertiary butyl group the below direction and the present in the equatorial orientation, so it is more stable conformation. But the second compounds, the tertiary butyl groups under flipping, one of the tertiary butyl group comes to that of the axial orientation, and hence the 1,3 diaxial interaction is present and it becomes unstabilized. And to stabilize this interaction, it goes to that of the twist boat conformation. Similarly, the isopropyl group always present in the equatorial orientation compared to the axial orientation, but in some compounds where the axial conformation becomes more stable compared to that of the equatorial conformation. Here this is the examples where the hydroxyl group can undergo intramolecular hydrogen bonding, can stabilize this conformation, and here the tertiary butyl group present in the axial orientation as the oxygen atom is present, so the 1,3 diaxial interaction is absent in that conformation. So the stability can be determined by their substituents. This is the bromine addition where the pyridine can add to that with the bromine to form the pyridinium derivative bromo compound, and then this pyridinium bromo compound react with that of the stilbene derivatives to form these brominium ions, and these brominium ions undergoes anti-addition to give that of the erythro compound, and this is similar to that of the B option. So this is the correct option. And if we add the phenol compound with the 2,4,6 dibromophenol, the excess addition will get that of the quinone derivatives, and this quinone derivative, that is the high electron rich, that is the aromaticity is lost here, and these quinone derivatives can also add to that of the aromatic compounds, and it is acting as the brominating agent to produce the bromo derivative. This has been taken from that of the Ledon books. Now this is the pericyclic reactions where the pericyclic reactions, here the on rotation ring opening take place, and we get that of the one substitution in the inside, another substitution in the outside, and after the disrotation ring opening, it go to the two hydrogen go to that of the anti-orientation, and these similar type problems is taken from that of the Ledon books. And last problem is the carbene additions. Here the carbene additions means the copper sulfate can produces the carbene, and this the sulfur can donate the vacant orbitals to that of the carbene and undergoes 2,3 sigmatopic shift to produces the substituted compounds, alkene compounds, and the correct option is the B. And similarly problems, they have the carbene is formed and the nucleophilic addition on this carbene to produces the ring, and similar nitrogen atom can add to that of the carbene derivatives to produces that rings, beta-lactam units. And thank you to see the video. Please subscribe this video.